Hello, this is Jay McCarthy from PrimeVault with our architecture series. In a past episode, I talked about how most custody providers are focused purely on providing cryptographic guarantees about their MPC algorithms, but they leave unspecified how secure their policy engine is. Well, at PrimeVault, we have built our security primarily using TEEs or trusted execution environments, where we run a reliable policy engine. In this brief talk, I want to talk about how one of the things that we offer is an MPC optional solution. Now, one of the main ideas behind MPC is that you have multiple parties that come together to run a shared computation that none of them would be able to run on their own with secret information that each one of them has part of that collectively produces some computation that would otherwise be done on a single node. Now, typically the way that this is deployed in practice is that the custody provider will hold one key share, one part of the secret information, and your organization or your employees, they'll have their own key share. And the multiple key shares all have to come together running the algorithm and the execution of the algorithm to produce signatures. Now, there's nothing about that architecture that makes it so we could not do the exact same thing in our TEE-based system. What I mean by that is that in the same way that our trusted execution environments, our enclaves, can generate a key entirely on their own, they could also just take part in an MPC algorithm. So they can start running one step of an MPC algorithm and rely on external communication router to send them, the messages, the next steps of the algorithm from the other participants and relay their messages. And that other party could be, your users, your organization. It could be like a totally different custody provider, or it could even be a different instance, like another instance of our software running on a different enclave. So the reason that you want to do this, of course, is that um, the idea of MPC algorithms is that you basically increase the cost for an attacker. They have to compromise multiple things simultaneously. And in our case, it's difficult to, compromise one enclave. So you might think that, oh, I could use more, and then that would even be more secure because you're dramatically increasing the cost to compromise the security principles that we guarantee. Now, something that's nice about TEE systems is that they're very flexible in being able to run a variety of different algorithms and code. It can run encryption and key generation algorithms directly in like a single node fashion. It can use envelope encryption to receive encrypted information from your existing custody providers without ever actually revealing it to anyone in the process. And as you transition to use PrimeVault, it could run instances of multiple different MPC algorithms. And all of these things can have the same trust guarantees that PrimeVault offers for its main usage. Because in all of these situations, the algorithm will be attested to by the hardware enclave's ability to guarantee what code's being run and when it's being run as well. And so what this shows is that while PrimeVault does have a different primary strategy, that strategy can be viewed as purely supplemental or complementary to an existing MPC strategy that you want to use. As an analogy, some of our competitors, they use MPC just for managing your keys, but they don't make any promises whatsoever about how the policy engine will use the secret information that it has. And you could then layer on top of that an MPC strategy, which makes the secret information that has only part of the key and not the entire one. Or you could have it use the entire key. And uh, you know, essentially, what you'd be doing with PrimeVault is that you would be starting with a secure base and then adding MPC on top of that. And if you want to use that, you can, or if you want to use the entire key, that's fine as well. We think it's fine to do both. But having the optionality of using MPC when you want is very convenient. And of course, there are advantages over not using MPC because MPC is very slow, and single node implementations are much, much more performant. And of course, the reason it's more performant is that you don't have to have multiple actors coming together. You don't have to deal with network communication, and oftentimes the algorithms themselves are just simply much smaller and less computationally intense. In our benchmarks, we can produce and sign transactions in under 2 milliseconds per signing, and you can generate new keys at a very similar speed. And that's not even using, high performance cloud instances that are used in production. That's just for, small testing instances. And so when you have high performance needs, you can opt out of using MPC if you want. But when you're particularly nervous, you could use MPC in addition to the other layers of security that we offer. So, for example, you could have your high frequency transactions happen in a single node fashion, but hold your treasury in keys that were protected with MPC. And so what this does is it makes it so that you can have the flexibility of a variety of different security strategies without forcing any particular complexity or particular security approach that may not be what you or your organization need at this particular time. And something that's nice is that, of course, you can change over time as well because the key is hidden inside of a secure enclave, which you could migrate away from a single node or to a single node, whatever you need. So as I said, this was on the shorter end of one of our architecture series. I look forward to talking to you next time in our next episode. Have a great day.